Today is your remote day, and here is a video showing you how to work these problems. Now, problem number 1 is a trinomial plus a binomial. How'd you know it was a trinomial? Because there's a plus sign and a plus sign. It breaks it into 1, 2, 3 pieces. Tri means 3, trinomial. Plus sign breaks it into 2 pieces, so that's a binomial. And what are we doing between them? We are adding. So if we are adding, I just want to combine like terms. I am not going to do the exponent rules. So if I'm adding or subtracting, I just need to get rid of the parentheses, and what numbers are sitting right in front of these parentheses? There's a positive 1 sitting there, and there's a positive 1 sitting there because it's addition. So when I distribute a positive 1 to everything inside here, do any of these change? Nope. Still positive x squared, still plus 5x, still plus 2. So I'm just going to pretend like I did it and the parentheses are gone. So just pretend like the parentheses are gone. You could rewrite it if you want. Positive 1, when I distribute it to both pieces, does anything change? Nope. It's still a positive 3x and still a positive 3. So I just pretend like I rewrote it without the parentheses, and now I can combine like terms. X squareds go with x squareds. That's 1x squared plus 3x squareds. So I have 4x squareds. Don't change my somethings when you're adding and subtracting. Combining like terms is adding and subtracting. And then I have 5x and no x's, so it just stays plus 5x. And then I have a lovely constant, with another constant. Those are like terms, and 2 plus 3, of course, is 5. There's your answer. I have no idea if it's A, B, C, or D. You go find out. All right, number 2. Again, it is an addition problem, so I am not following the exponent rules. I am just combining like terms with adding and subtracting. I just want to be able to put the x squareds together, but they're not in the same parentheses, so I need to get rid of parentheses. So I look to see what's right in front of it. There's a lovely positive 1. When I distribute that, does anything change? No, so I'm going to pretend like that parentheses is gone. And you can rewrite it if you like. What number is sitting right in front of this one? Also a 1, and since it's adding, it is a positive 1. And when you distribute a positive 1, does anything change? No. So I'm going to pretend like that. Parentheses is gone. And then I notice there's another set of parentheses over here. And what's happening between them? Also addition. I already got rid of this parentheses. But we are adding. So what number is sitting right in front of that one? Another positive 1. When you distribute, does anything change? No. So I'm going to pretend like I rewrote it, and the parentheses are now gone. So distributing a positive 1 does not change anything, and I can just pretend like the parentheses are gone. I see an x squared, no x squareds. I've got x's, no x's, x's. And then I have a lovely plus 2, plus 3, and plus 11. So those are the ones that I'm grouping up together. The single x squareds, or the single lines x squared, so 5 minus 2. 5 minus 2 is 3x squareds. So this is going to be, I'm going to write it down below, 3x squareds. So I'm not changing my somethings. Now I'm doing the x's. I have a negative 4 and a positive 12. So negative 4 plus 12, you can put it in the calculator, or if you do it in your head, 4 of these kill 4 of those, so I've got a positive 8x left over. And then I need the constants. I have a 2 plus 3 is 5, and 5 plus 11 is 16. So there is my final answer on that one. Go find the answer that matches that. Number 3, I see this lovely trinomial here, subtracting another trinomial and adding to that a binomial. So I know I'm adding and subtracting. I'm not multiplying these or add, subtract things. So I need to just combine like terms, which means I just want to get the parentheses gone. So what number is sitting right in front of it? Positive 1. Is anything going to change when I distribute positive 1? No. What's sitting right in front of this parentheses? A negative 1. When I multiply each of these pieces with a negative 1, are things going to change? Yes. This is no longer a positive 5x squared. It is now a negative 5x squared. Right now inside this parentheses, it was a plus. They didn't write the plus, but it's there. And when I distribute negative 1 times this is no longer a positive x, it's now a negative 1x. I'm going to go ahead and write the 1 so you can see it. And negative 1 times positive 3 is now a negative 3. But now that is gone. It is no longer subtraction, and those numbers no longer exist. These are the new ones. Now, another parentheses down here. What's sitting right in front of it? A positive 1. When you distribute, does anything change? No, so I'm just going to pretend like I rewrote them, and they are all out of the parentheses. So we're just going to combine like terms. So I'm going to go through and look at the squareds first, because I don't think I saw any cubes. So I've got 2x squared minus 5x squared. So 2 good guys, 5 bad guys, I'm at negative 3x squareds. Any more x squareds? No. So this is going to equal negative 3x squared. And then I'm going to do my x's. Here are some x's, and there's an x. So I have 5 minus 1 is 4x plus 3. So I had 4 plus 3 is now 7x. And that was 5 minus 1 plus 3. And then I have my plain numbers. I've got a 2 minus 3, and that gives me negative 1 because 2 of those kill 2 of these. So I'm at negative 1 plus 5. My one bad guy kills one of my good guys, so now I'm at plus 4. Plus 4. And that's my answer. There's no like terms there, so I would go find the answer that matches that. Number 4, I see a parentheses. It's a lovely binomial. I see something here in front of it, but is there any pluses or minuses between them? No, so it's not addition, subtraction. It is just multiplication. Is this a monomial or a binomial? It's just a monomial, so it's just one piece that needs to be distributed. So negative times positive is a negative answer, and 3 times, there's a big 1 here. 3 times 1 is just 3. And then I have x times x. And when you're multiplying, you add the exponent, so this is now x squared. And then I'm going to multiply the negative 3x times this. Negative times positive will be a negative answer. 3 times 7 is 21. And x times no other x's will still have an x in the answer. And that's it. I distributed it twice. It's done. Parentheses are gone. These are not like terms, so I am finished. Number 5, I see a trinomial, 3 pieces in there, and I have an x squared in front of it. There's no plus or minus between it, so it is not adding or subtracting. It's simply multiplying. And this is a monomial, not a binomial, so I just need to distribute it 3 times to all the pieces in there. So x times 5x squared. There is a 1 in front of here if you want to think about that. 1 times 5 is still just 5. And x squared times x squared is x to the 4th. And then I'm going to multiply it times the next piece. 1 times 3, they're both positive, so that's a positive 3. And I have x squared times a single x, so add the exponents, that's x to the 3rd. And then I'm going to come back and multiply it times the last piece. So that is a 1 times 2, which is still 2. 1 times 2 is 2. Remember, when you're doing distribution, we are multiplying. So 1 times 2 is 2, and it's positive, and x squared times no x's is still x squared. And then I have the 4th power, 3rd power, 2nd power. None of those are like terms, so that's as far as you go. Oh, look, number 6. What's happening between the parentheses? It is multiplication. Is this a binomial? Yes. And is this front piece also a binomial? Yes, it's not a monomial, so this is your double distribution. X times 2x. 1 times 2, because there's a big 1 in front of this. 1 times 2 is 2, and x times x is x squared. 1 times negative 1 is a negative 1, and x times no x's, it stays x. And then positive 5 times positive 2 is a positive 10, and there's an x here, but no x's here, so it stays with an x. And then I have a positive 5 times a negative 1. We're multiplying, remember, so that's negative 5. Like terms, these two are like terms, so I still have 2x squared. Negative 1 plus 10 is positive 9 x's. Don't change my somethings. Minus 5. So there is my final answer on that binomial times binomial. Number 7, another multiplication problem, a binomial, also a binomial in front. So again, it's a double distribution. 2 times 4 is 8, and x times x is x squared. 2 times a negative 1 is a negative 2, and x times no x's stays x. 2 times 4 is going to be a positive 8. Whoops, can't make that 8 very pretty. I'm going to make a loop down here. Pretend that's a pretty 8. And then no x's times x means I still have a single x in the answer. And then I have 2 times a negative 1. Positive 2 times negative 1 is a negative 2. Come on, there we go. Hold that paper. Now, like terms, the two x's go together. So I still have 8x squared. Negative 2 plus 8. 2 of these are going to kill 2 of those, so I have a positive 6 x's. Don't change my x's. And then minus 2. And there's the answer to that. Those are not like terms, so there's your final answer. 8x squared plus 6x minus 2. All right, number 8. This one gave you a rectangle, and they say find the area. How do you find area? It's length times width. Now, they gave you the length and the width. They did not put parentheses around them, but remember I told you, you always put parentheses around the sides or the lengths in geometry. So this is actually a binomial times a binomial. So that's how you know to do double distribution. not just multiply these two pieces right next to each other. 2 times 5 is 10. X times x is x squared. 2 times my 1. 2 times 1 is 2, so that's a positive 2. And x times no x is x. 3 times 5 is a positive 15. No x's times x means I still have an x in the answer. And 3 times 1 is a positive 3. Like terms, those two are like terms, so finally I have 10x squared. I'm going to have to write this, hold the paper. 2 plus 15 is 17x's, and I still have the plus 3 on the end. So those two became a 17x. 2 somethings plus 15 somethings is 17 somethings. And of course the 10x squared and the 3 stayed as they were. All right, last one, number 9 on this one. This whole parentheses is being raised to the second power. Now remember, I said you can't use the reference sheet for their power rules because that power rule only applies to a monomial, and we don't have a monomial, we have a binomial. So the easiest way to do these is to literally just square it. This whole thing is being squared, so this is 3x minus 4 times 3x minus 4. So I'm going to rewrite that, 3x minus 4 times 3x minus 4. So squaring something means take the base times itself. So 3x minus 4 times 3x minus 4. This is a binomial times a binomial, what we've been doing. 3x times 3x is 9x squared. I probably have to stop and write when I do this. So 3x times 3x is 9x squared. 3x times a negative 4 will be a negative 12 with a single x. And then I'm going to come back and distribute the 4. Negative 4 times 3 is a negative 12 again with a single x. Minus 12x. And then I'm going to come back and do negative 4 times negative 4, which is a positive 16. And then your like terms are these two 12x's in here. Now these are not opposite signs, so this is a bad guys and more bad guys, so these are 24 bad guys. So that middle term became 24x. You still have the plus 16 on the end, and you still have the 9x squared out front. So there is your final answer on that one. 9x squared, these two became negative 24x, and that's your 16. All right, the last one that's on this one, number 10, is a really lovely problem. It is what kind of operation is happening here? It is multiplication. So this is some sort of a distribution thing. Is it a monomial or a binomial? Yes, that's a binomial. So this is a double distribution. This first piece is going to get distributed to everything over here. The second piece is going to get distributed to everything over here. The only thing different, instead of the second piece being a binomial, it's a trinomial. But it's still the same process. X squared times the first piece. So x squared, well, there's a 1 in front of this. Let's put the big 1 there. 1 times 3 is still 3. X squared times x squared is x to the 4th. 1 times 2, let me just do my line over here. 1 times 2 is a positive 2. And x squared times a single x is x to the 3, which we add the exponents. 2 plus 1 is 3. And then we're going to multiply this 1x all the way over here to the 6. So 1 times 6 is 6. It's a positive 6. And I have x squared times no x's, so that stays x squared. And then I'm going to come back and multiply this piece. 3 times the first one, 3 times 3 is 9, and it's got an x squared with it. And then I'm going to multiply the 3 times the second piece, so 3 times 2 is 6, and there's an x with that. And then I multiply the 3 times the last one in here, which is a positive 6. So 3 times 6 is 18, and there are no x's with this piece. And then I go back and look for like terms. So I have an x to the 4th, and I don't see any other x to the 4th, so this is going to stay 3x to the 4th. X cubed, any other x cubes? Nope, so that's going to stay plus 2x cubed. Squares, oh, there's two squares here, 6x squared and 9x squared. So 6 plus 9 is 15x squared. I'm not changing my somethings. And then I have a plus 6x, and I don't have any other just plain x's, and I don't have any other constants, so that's it. I've got an x to the 4th, x to the 3rd, x squared, x to the 1st, and 18, and there is that answer. Woo, wasn't that fun? Y'all have a great weekend. See y'all Monday.